Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Jr., your math tutor. In my today's lesson, I will be looking at solving system of linear equations in two variables by graphing. So let's look at the first problem. The first problem says we must solve the system of these two equations by graphing. So I'm going to show you some easy steps, two major steps that you can use to solve this by graphing. Just two steps. So we consider the first equation, y equals to 3x minus 2. So step one, find the y-intercept. So the y-intercept, it is a point at which x is equal to 0 and y is equal to some value b. That's exactly what we call the y-intercept, because when you have a graph, when x is 0, it means you must now go on the y-axis for its value, right? So when y is some b, it means it's going to intercept the y-axis at certain point b. So this is what we refer to as a y-intercept. The x-intercept, you have y to be 0 and x to have some value a. We call it a, some value a. That is, when x is some a, y is 0, so it remains on this axis. Okay, now, so step 1 says we must find the y-intercept. So remember that this is your x-axis and this is your y. So let's find the y-intercept. We take the equation y equals to 3x minus 2. So when x is now 0, so we say when x equals to 0. So what do we have? We replace x with 0, so we have y equals to 3 times 0 minus 2. So 3 times 0 is just 0, so you have y is equal to minus 2. So therefore, you will have the point, the y-intercept. The y-intercept will be 0, comma b. B now is representing our minus 2. Or minus 2 is representing our b. So there's the first step. The second step is step 2. Find the slope of the line. So the second step is for us to determine the slope of a line. Now take note that the slope, which is also equal to m, right, is equal to change in y divided by change in x. And I will come back to this. Right? And we know that change in y means the difference from the big Y and the small y. That is y2 minus y1 all over x2 minus x1. Now we'll come back to this. We'll use that. But let's look at this equation. So y equals to 3x minus 2. Now we know that this is of the form y equals to mx plus b. Now the slope intercept form, right? So if you have this to be the equation, now if this equation was not in this form, we would have rewritten it in the form, thereby solving for y, right? In the second example, we might see something like that. So we see that our m is just equal to 3 and our b is equal to minus 2, the same thing that we had right there, minus 2, right? So we have the slope now to just be equals to 3. But we know that slope is equal to change in y, right, all over change in x. So it means there must be a denominator. So the change in y, that is the difference. This is the y, right? So if you have a big y and a small y, so the difference between these two now is 3. And also the difference between x1 and x2, for example, is 1. So if there is no denominator under the slope, just add 1. So if this is, for instance, 2, it means we must move 3 units in the y direction, and then we move 2 units in the x direction. That's exactly what we need to do. So now we've gotten the slope and the y-intercept. Let's graph. So let's put them one side. The y-intercept is just this expression, which is the y-intercept we have 0 comma minus 2. So now let's graph. Very, very simple. Now, if we graph this first one, we still have to do the second one, right? So let's graph it, and then we just include this one within it in the same graph. So excuse me for my freehand drawing. Okay, so now what I need to take note of is the values. In the slope, I have 3 over 1. So I have 3, I have 1, you have minus 2. So the highest number I'm dealing with is 3. So I don't have to, to draw kind of large graph. So I can freely say this is 1, this is 2, this is 3, this is 1, this is 2, this is 3, this is 1, this is 2, this is 3, and so forth. This is 1, this is 2, and so forth. So let's graph now. The first one, when x is, this is the y-intercept. When x is 0, we must move 2 units where? In the negative y direction. So it's 1, 2. So right there. Remember this is negative 2, negative 1. So right there. So this is right here. What's the next one? Then they said from this point, from this particular point, we must move 3 units in the positive y direction. This is 3. So we say from this point, we move 1, 2, 3. Then we should also move 1 unit in the in the x direction, 1. So it's like you are forming a kind of slope, right? So we move it like this. So from here now we run a line through it, straight upward. So this is the first graph. This is the first graph. Now if you have a kind of unique, drawing pad, you could like drawing paper, maybe the lines, all of the lines could be, could be drawn like this. And then you see something like this. Yes, you could just see something like this, probably. Probably you could see something like this, and so forth. Okay, now, so let's move to the next one. Y equals to minus x plus 6. So the same thing we did for the first problem, that's the same thing we are doing for the second problem. So the first thing we need to do is to find the y-intercept. So the y-intercept will just be minus x plus 6. So since it is in the form of y equals mx plus b, it means that our y-intercept will just be the 6. That is The y-intercept now is x is 0, y is 6. And then for the slope is just the coefficient of this x. So m is equals to minus 1. So we know that this is also 1 down there. So what do? We graph the first one, the y-intercept. When x is 0, y is 6. So we must move 6 units upward. So we have 1, 2, 3, 4, 5. Now I have to erase that. 5 and 6. 5, 4, 3, 2, 1. So yes, we have to move it like this, something like this. So let's select this. So now we have when x is 0, y is 6. So this is 6, right? So what do? We move 1 unit downward because it's negative. So move 1 unit downward from the 6, 1 unit downward. And then we move 1 unit in the right direction, right? So it's like something like this. Yeah, something like this. Yeah, something like this. So what do you observe? We observe that the both graphs intercept at a particular point. And what is that point? You have 1, you have 2, you have 3. Now, when x is 2, y is what? Y is 4. So the point is 2, 4. So there's the solution. So if you want us to verify, we will verify that solution by solving the system to get the same solution. So the system is y equals to 3x minus 2 and y equals to minus x plus 6. So if we can use whatever method we want to use, if we use a substitution method, now this is equation 1 and this is equation 2, for instance. So if we take the substitution method, that is, we replace equation 2 within equation 1. So equation 1 is y 3x minus 2. So that's why we see y in this equation now. We can replace it with this one, which is minus x plus 6 equals to 3x minus 2. So we can solve for x. So this is, we put all of the like terms one side. This x, now another x is on this side, is 3x. So we send this 3x across, it becomes negative 3x equals minus 2. We send this 6 across, it becomes negative 6. From positive to negative. So minus x minus 3x, the signs are the same. What do? We add and take one of the signs when the signs are the same. So it becomes negative. Now here you have 1x. So it is 4x equals, now minus 2 minus 6, the signs are the same, is 8. So it's minus 8. Now we want to solve for x, so we can divide this out by minus 4. And we divide this out by minus 4. So 4 we cancel 4. You have x to be equal to 2, positive 2. Now, from the solution, we have x to be equal to positive 2, right? So we'll do the next one. So when x is now equal to positive 2, we can determine our y. Let me solve that quickly. So we determine our y now by saying we can take any of the equation. Y equals to 3x minus 2. So y now is just 3 times, what is x? X is 2. 3 times 2 minus 2 So you have 3 times 2 is 6. So y is equals to 6 minus 2. And then y is equals to 4. So we see that when x is 2, y is equals to 4. So this is how we solve a system of linear equations by graphing. But mind you now, you have to always use the graphing paper, or you take your time to draw these, these boxes, so that you can be able to determine the exact point of the solution. So thanks ever so much for watching. See you in our next video.